Welcome to Biology My Passion. I am Soumya Harikrishna. We are going to learn a new chapter in physics, force and laws of motion. In the previous chapter, motion, we talked about velocity, uniform velocity, non-uniform velocity, acceleration, all these aspects of motion. But we forgot to discuss one thing there. What causes motion? So let's discuss that aspect in this chapter. The study of causes of motion or change in motion is called a dynamics. So we are all familiar with the concept of force. That means force can be considered as a push or a pull or a hit. When you are opening a door or lifting at an object or picking up something, that is kind of pull. When you are throwing a ball or you kicking a football or you are moving something, that is a kind of pushing force. At the same time, we are beating a drum or hitting with a hammer. These are all hit. All these kinds of actions are ending up in force. We cannot see or taste or feel force as such, but the effect of force can be felt. So, what are the effects of force? Force can make a body in motion from its stationary position. For example, if a train, if you consider its engine, is using a force to pull all the compartments along with it. Or if there is a ball which is stationary, you can apply a force or kick it so that you can make it move. Or if I am pushing this side, I can move this board to one side. Or I can take a book or I can push a book on the table and make it move. So force can cause motion in a stationary body. At the same time, we can stop certain things also. For example, if there is a small baby coming in a tricycle, we can stop it. I am talking about small cycle because if it is a big vehicle, it is not possible without force. Okay, so if it is a small cycle, we can stop it. Or if a ball is rolling towards us, we can stop it. Or if there is you are playing a cricket ball, you can take a catch. Thereby, you are stopping the motion of the body. So it's not only that we can set motion in a stationary body, we can stop the motion of a moving body also using force. Next is force can change the direction of the moving body also. The best example is in the case of cricket. Suppose a bowler is bowling, the batter is hitting the ball. At that time what he is doing, he is changing the direction of the ball. And also, that's the third effect, force can change the direction. And also force can change the velocity. Suppose a particular body is moving with a speed or velocity in one direction. If you apply force, we can increase the velocity or you can decrease the velocity also. So the speed also can be changed by applying force. And finally, we can change the shape of an object also by applying force. Suppose you have a clay ball, you can press it and it will be squeezing, or you can flatten it by applying the force. Or if there is a rubber band, you can pull it, you can change the shape of it by applying force. Or there is a thin silver, you can beat it into thin sheets. That is also by applying force we are changing the shape. So these are the effects of force. That means force can make motion in a stationary body. At the same time, it can stop a moving body. It can change the direction of a moving body, or it can change the velocity or increase or decrease the velocity of a moving body. Or finally, we can change the shape also of a moving body using force. These are the effects of force. So how can we define force? Force is a push or a pull acting on a body. Body means any object in which the force is acting. Suppose if I am pushing this board, this body is this board. Okay, so it is a push or a pull, because now when I am moving, I am pushing it, but now I am pulling it back. Right, this is pull. So it can be a push or a pull on a body which changes. Okay, it can change. In this case, it's changing because less force is required, or it tends to change the state of rest. Means it was at rest. Rest means what? Not moving. So when we are pushing, we are trying to change the state of rest. Or uniform motion. Already it's going in a uniform motion. We are changing that. Or the direction of motion, as I mentioned, or the shape and size of the body. So all that we discuss now are coming here. So force is either a push or a pull. Where is it acting? Acting on a body. Then what happens? It changes or tends to change what? The state of rest, because if it is rest, we can make it move. Or uniform motion. If it is already moving, we can make it move faster. or we can change the direction of the movement, or the shape and size of the body also can be changed. So these are the different effects of force, and finally the definition of force. Now let's learn about the concept of balanced force and unbalanced force. So what is mean by balanced? Balanced means something is equalized, right? So if there is an object kept here, maybe on a table or on a surface, and this X is a pulling force. If I am pulling it, I know that this body is going to move towards me. Suppose if it is pulled from this side, then this body will tend to move to that side. But if we are pulling with an equal force from both the sides, then what happens? Will it move? No. For example, suppose this phone, if I am pulling this side, it will come to this side, or here also it will come. But I am pulling like this, it is not changing its position, neither to this side nor to this side, it's staying in its position. So that is how, that's called a balanced force. So balanced force cannot make a body at rest to move. It will remain in the state of rest as long as we are applying a balanced force. Now imagine a toy car is moving already with a particular uniform velocity. It's going just like that. Again, if you apply a balanced force on that, it's not going to change its velocity. So change in velocity, do you know what we learned in last chapter? If there is a change in velocity, that is called an acceleration. So balanced force, if applied on an already moving body with a uniform velocity, it is not going to change the velocity, or there is no change in acceleration also. And we know that these two forces are equal in magnitude. As long as they are equal in magnitude, but they are opposite in their direction. That is what is called what? The balanced force. When a number of forces acting simultaneously on a body is not bringing about a change in its rest, or not bringing about any change in its uniform motion in a straight line, then we call these forces as balanced forces. But take a balloon. If you are pressing the balloon from both the sides using your hands, but equal force you are applying, then you know that it can change the shape. So balanced force can change the shape of the object. Now let's discuss what is unbalanced force. Suppose if I am pulling a force with a X this side, I am pulling with a Y, but if Y is stronger than X, you know that the body will go that side. If X is more, then body will come this side. So that is what is used in the case of tug of war. So one team will win, who is having more force will win. As long as it is a balanced force, you know that nobody will win. It will go on for some time, and finally one team will be winning, because when there is a unbalanced forces created. Unbalanced forces can change the speed of a moving body. For example, if you are using a cycle, so initially the cycle is at rest, but once you start pedaling, you are applying some force and it starts rolling over the surface, whatever it is, if it is a road or a kacha road. What happens is the road has got some friction, means an opposing force is there, and we have to apply a force more than the frictional force to overcome it, so that our tire will roll over the road. But after some time you are thinking, okay, I will now relax, my legs are paining, I will relax. You stop pedaling it, you know that the cycle will go for some time, but it is slowing down and it will come to stop. Why? In that case, the frictional force is more than the applied force. So it is an unbalanced force acting here. Then if you want to continue, you have to apply a force or pedal the cycle with a more force than the frictional force applied on the cycle. So the unbalanced force can not only change the speed of a moving body, but it can also change the direction of the moving body as well. When a number of forces acting simultaneously on a body can bring about a change in its state of rest or state of uniform motion, then these forces are said to be unbalanced. So unbalanced forces can make a change in the state of rest or state of uniform motion in a straight line. These two unbalanced forces acting on a body can change its state of rest or state of motion, uniform motion in a straight line. And what is their condition? Their magnitude should be different. Unlike the previous one, here the magnitudes are different, but they are acting on opposite directions. Thousands of years back, it was believed that the natural tendency of the body is to remain at rest. But later, there was an experiment done by Galileo. What he did was, he took an inclined plane and used a ball to roll it down through the inclined plane. This plane was made as smooth as possible to reduce the friction, maximum reduction in the friction, and also apply lubricants over that to reduce the friction even further. So very minimal friction was there. So what happened or what noticed was, he released a ball from this inclined plane AB, and there is another inclined plane CD with the same angle of inclination. So when it is released, it rolled down. And he found that when it is rolling down the slide, this slope, the velocity increases, or the speed is increasing. It's coming down, it's increasing. And when it is going up, the speed is decreasing. But if it is going in a horizontal path, it is going with a uniform velocity, no change in the velocity. So when it is rolling down, the velocity is increasing. When it is rolling up, velocity is decreasing. But if it is going on a horizontal plane, from here it is going with a uniform speed. But remember, he kept the friction very less. Now, what he observed was, when these two angles were equal, that these two inclinations were equal, he found that when the ball is rolling down from here, and then it will climb up to reach the same height here. Okay? In the second case, he made another inclination. The next is lesser inclination. Then he found this ball is moving to reach the same height, but it is traveling more distance. One more time he reduced the inclination. So here again the ball is rolling down and reaching the same height, but it is traveling even further. But later he observed, when the slope was made 0, the ball will be rolling with a uniform speed continuously. That is an ideal situation. But we know that in real life situation, what happens? This ball will slowly come to a stop. Why? Because, as I mentioned earlier, there is a force acting against this from the surface, that's called a frictional force. So because of the friction, it will slow down and finally come to a stop. But if there is no friction, this would continue. So this was actually the theory of inertia. So based on this very classical finding of Galileo, later in 17th century, Sir Isaac Newton, he formulated 3 laws of motion, and the first law of motion we will learn now, which is also called a law of inertia. According to the first law of motion, every body tries to remain in its state of rest or state of uniform motion in a straight line until acted upon by an external force. That means, suppose if there is an object, it is sitting at rest, it will remain in rest position until there is a force acting on it. See, it is sitting, suppose you keep a book on the table and you are coming after 5 minutes and seeing the book is still there, it has not gone anywhere. If you are coming after 5 hours, still the book is there. Until it is not disturbed by anyone else at home, not coming and disturbing. You are the only person at home and you are keeping it there. And after 5 days if you come also, the book is there. And after 5 months if you come also, book is there. If you come after 5 years also, the book is there. Why? Because it is remaining in its state of rest, because there is no external force acted on it. Or the same case like this, if it is going in a uniform motion on a straight line also, until and unless acted upon by an external force, it will keep on moving with the same uniform velocity. This is called Newton's first law of motion. So here we can infer 3 things, that is, body at rest will remain at rest until an external force acts on it. A body moving with a uniform velocity will continue to be in that state until acted upon by an external force. Or a body moving in a straight line will continue in that straight line without changing direction until acted upon by the external force. This is the essence of our Newton's first law of motion. So whatever a body is doing, it will continue to do until and unless there is a external force coming. Very typical example, when we start scrolling the mobile. Okay, suppose you are checking your Insta or some reels you are watching, we keep on watching till our parents are coming. That's the external force, right? So then we keep the mobile down, or they will scold us, oh, how long you have been doing it. Until and unless there is no external force, we will be doing the scrolling for endless hours. So this first law of motion can also be called as law of inertia. So that is the inherent quality of any object or any body to remain in its own state, whatever state it is in. It can be in a state of rest or state of uniform motion, or in a particular direction, straight direction it is going. It will tend to remain in that particular state. That is, the tendency is called a what? Inertia. So if you want to change, what should we do? We have to apply a force. So you can keep the book there and let it remain there forever until and unless we make it, take it or push it or pull it or drop it or throw it, it will be there. Okay, or something is moving, until we apply a force, it will keep on moving the same way. But again, you keep in mind the friction. Okay, ideally speaking, friction is not there only, it will move. But friction is a force which is making it stop. So this is called the law of inertia. So the inertia can be observed in different cases in our day-to-day life. The best example, there can be inertia of rest or inertia of motion. Inertia of rest is best explained, if these both can be explained in our day-to-day life while moving in vehicle. Imagine this is you, it's an astronaut only. Okay, but suppose this is you. So you are getting on a bus and you are standing, you didn't get seat, you are standing here on the bus. All of a sudden the bus starts moving. So when the bus starts moving, along with that the feet touching the bus also moves forward. But you are still, your body is remaining at rest because you are not moving, right? So all of a sudden your body still remains there because that's the tendency, inherent tendency of your body to remain at rest. That's called inertia. But the feet starts moving. So as a result you will fall backwards. We know that we move backwards, all of a sudden the bus takes. Okay, so this is called the inertia of rest. Or another example is on a tree, all the leaves are all, or the flowers, fruits are all stationary. But all of a sudden if there is a wind, then what happens? The leaves and all the things will start fluttering. The leaves start falling. The same physical principle we do in our day-to-day life when we are dusting out our pillows and our blankets or our carpet. While we are sweeping the floor, you know that we take the doormat and we just tap it. Once you just tap it, you can see the dust falling off. Why? The dust was in a state of rest. When we are tapping or just hitting it on the wall, we are making the carpet move, but the dust particles are still in a state of rest or inertia of rest. As a result, they fall down. Okay, so this is the method that we are using. Or while after washing, we just spread the cloth once, jerk it, and then we put it on the cloth line because we want the water to go off from that maximum. So there also water molecules are in a state of rest, but all of a sudden we are jerking the cloth, we are moving the cloth, so that will fall off, water will fall off. An example, a glass is there, over that we are keeping a cardboard and then a coin. Then we are just flicking the cardboard, then only the cardboard will fly, but the coin will end up inside the glass. Why? Because it's a sudden motion we are giving, sudden force. As a result, the cardboard will move, but the coin is still in a state of rest, it will fall off. And or another example is there in the caroms. We are keeping many coins on above the other like a pile, and with a striker, if you are hitting the bottom one, if it is a very quick movement, we know that only the striker can remove the lowest one, but the rest all will just land the same way as a pile on the carom board. These are all examples of law of inertia of rest. The exactly opposite is happening with the law of inertia of motion. That means if the bus is moving, you are also moving along with the bus, but all of a sudden your body is moving forward, right? But all of a sudden the bus stops, so the feet in touch with the bus stops, but the body is still in the state of moving. So it will tend to move forward. So when the bus is stopping, all of a sudden we all tend to bend forward. Or if it is in a car, we all of a sudden the car brakes, we all will come or we lean forward. So that to avoid that, we are using the seat belt. Seat belt will apply a force opposite to that to prevent us from hitting the dashboard. Then the same way, We can explain also. You have seen, though it is dangerous, you must have seen people jumping out of the bus which is slowing down, or train when it is slowing down they are getting down or they coming up. Never try that. Even if it is very slow, please wait for it to completely stop before you get onto the train or come out of the train. Please be careful. Okay, but I'm just telling an example. Those who are getting out of the train for some reasons, especially the vendors who are selling the tea and other snack in the train, they after just the train is moving itself, they come down. But you know that they will be jumping down. After that, some distance they will be moving to stabilize themselves. Otherwise, what happens? Suppose from a moving train you are jumping out, then you will fall, because you are still, your body is in a the state of motion forward, but you are all of a sudden you are jumping, means you will fall forward. So to avoid that, we run little bit and then only stop. The same way, those who are jumping onto the moving bus or train, they run with that and then jump. Otherwise, what happens? Again, the chance of falling is there. You must have seen when people are going to the airport or coming back. Nowadays, we can keep in the dicky, but still on top of the vehicle, if you are keeping, always we tie with a rope. Otherwise, what happens when we are braking somewhere, the luggage will fall over our car to the front. Why? Because still it is in a state of motion. We are all of a sudden stopping it, so it will fall forward. So these are the examples of the state. The inertia of rest and inertia of motion. Think clearly and then answer the questions that is coming to you. Now think of a situation when I am keeping a small tennis ball. That means the plastic one, no, we get for just for fun. The small one, if I keep, even if I blow with that force, it will move. But at the same time, if I am keeping an iron ball of the same size, but it won't move, I have to apply a force. But if it is a rock, it may take even more force to move it. The same way, if a cycle, you can, suppose your little brother or sister cycling, pedaling, you can help them by pushing them. But if it is a truck, can you help? No, it will not move with your force. So here, there is a relationship between mass and inertia. That is, if the mass is less, the inertia is also less, so we can overcome that very fast. Just by applying a force, you can overcome that inertia. But if the mass is huge, that we need more force to overcome that. So mass is less, inertia is also less. Mass is high, inertia is also high. And Newton's first law is rightly explaining the concept of inertia. His first law is also called the law of inertia. Hope you understood all these concepts well. If so, please share with your friends and subscribe to my channel. Leave a comment if you have any suggestions or doubt. Thank you for watching Biology My Passion.